Hello everyone, welcome back to a differential calculus tutorial video, and in this video I will discuss additional problems, example problems for derivatives of exponential and logarithmic functions. So let's go ahead and answer our first problem. So first problem, we have y is equal to ln x over the square root of x, and we have to solve for the first derivative, y prime, or the derivative of y with respect to x. So as we can see here, the first formula that we are going to apply is the derivative of a quotient. So we have square root of x and then derivative with respect to x of our ln x, then minus ln x times the derivative of the square root of x all over the square root of x squared. So square root of x, what is the derivative of ln x? Is simply 1 over x minus ln of x. Then derivative of square root of x, we could have this square root of x in your mind. You could think of it as x raised to 1 half. So if we apply the power formula, we have 1 half x raised to negative 1 half, and then derivative of x is simply 1. And then square root of x squared is simply x. So let's continue simplifying. So we have square root of x over x. So that would be x raised to negative 1 half minus ln of x times 1 half. We could have 1 half here. Let's write 1 half at the first part of our ln of x. So we have minus 1 half ln of x, and then x raised to negative 1 half over x. Now, we could factor out x raised to negative 1 half. So what we'll have here is simply 1 minus ln x over 2. And then we have x all over x. So the denominator will now become x raised to 1 half plus 1. So that would be x raised to 3 halves. And then this one, if we get the LCD, we have 2. So it will be 2 minus ln x all over 2. So the simplified answer would be 2 minus ln of x all over 2 times x raised to 3 halves. And that would be our final answer. Problem number 2, we have y is equal to ln of secant x plus tangent x all over secant x minus tangent x. So we have to solve for y prime, and the one way of solving this is, instead of solving this as it is, no, we have a quotient here. You could first transform your problem as y is equal to the ln of secant x plus tangent x and then minus the ln of secant x minus tangent x. Now this is easier to solve because here you would have to deal with the derivative of a quotient. So for me that is easier, but if you do not want to follow this, then you could just go ahead with the derivative of the logarithm du over u. So now I have it separated. I could get the logarithm of each separately. So ln of secant x tangent x, the derivative is the derivative of u with respect to u. So our u here is secant x plus tangent x all over secant x plus tangent x minus the derivative of secant x minus tangent x all over secant x minus tangent x. So y prime is equal to, so derivative of secant, we have to recall our trigonometry. Derivative of secant is secant x tangent x plus derivative of tangent x is secant square x, and then all over secant x plus tangent x minus, so here derivative again of secant is secant x plus secant x tangent x, and then minus secant square x for the derivative of tangent. Then all over secant x minus tangent x. So this is just a matter of simplification. So if we will get the LCD to be secant x plus tangent x times secant x minus tangent x, then we will have secant x minus tangent x times secant x tangent x plus secant square x, then minus secant x plus tangent x, then we have here secant x tangent x minus secant square x. Okay, so it's a bit long, but bear with me here. So secant x plus tangent x times secant x minus tangent x is simply secant square x minus tangent square x. And then if you notice here, we can factor out secant x. Okay, and this will be tangent x plus secant x. And then here we could also factor out secant x, and this will be tangent x minus secant x. So this term multiplied to this term would become secant square x minus tangent square x. Okay, and then times secant x for this one minus, so this term again multiply to this term would yield the same result, but this time since this is tangent minus secant, so therefore this is tangent square x minus secant square x. Okay, and then times secant x. So we can factor out secant x, and actually for this term and this term, this is basically the same. If you distribute the negative here, then this will be secant square x minus tangent square x. Okay, so this will be two actually this will be two similar terms, I should say. So it will be now become 2 secant x times 2 secant x times secant square x minus tangent square x, and then all over secant square x minus tangent square x. So what will happen there is this one cancels out. Okay, those two would cancel out, and then we will simply have our final answer will simply be 2 secant x. So problem number 3, we have y is equal to ln of x over the square root of x squared plus 1. So again, if we will apply the properties of logarithm, and then this will be ln x minus the ln of the square root of x squared plus 1. Now I prefer to, just like in the other problem, simplify this first, because I think that would be easier than getting the derivative of the ln of this ratio, and that would be the derivative of x over square root of x squared plus 1, then all over x over x squared plus 1. So I think this is easier than this one, but it's up to you if you want to continue with this one or you want to simplify it first, just like what I did here. So we have y prime is equal to, so ln x is simply 1 over x for its derivative. And then we have ln of x squared plus 1, so derivative of ru here, so it will be 1 half x squared plus 1, then raised to negative 1 half, and then derivative of x squared plus 1 is simply 2x. Then we have here all over the square root of ru, which is x squared plus 1. So we can cancel out 2, and we could continue simplifying this. 1 over x minus, so in the numerator, we'll have x over the square root of x squared plus 1, and then all over x squared plus 1. So what will happen is that you'll have 1 over x minus this x squared plus 1 here will go to the denominator and will simply be x squared plus 1. If you add the exponent, it will be 1 half plus 1 half, and that would be 1. So the numerator is simply x, and we could get the LCD as x times x squared plus 1. So this will now become x squared plus 1, and then minus quantity, or not quantity, it will simply be minus x squared. Okay, so simplify, x squared minus x squared is 0. So our final answer would be 1 over x times x squared plus 1. Okay, so let's go to our next problem. So we have number 4, y is equal to x squared times e raised to 2x, and then sine 3x, find the first derivative. So we have here 3 terms. So what we're going to do for the derivative is combine 2 terms first and then get the derivative of the third. So the derivative of sine 3x, and then plus, let's combine e raised to 2x and sine 3x. So therefore we will get the derivative of x squared, and then for the last we have x squared and then sine 3x, and then we'll get the derivative of e raised to 2x. So let's answer the derivative. We have x squared e raised to 2x. Derivative of sine is cosine. Now your u here would be 3x, so therefore the derivative of 3x is 3. So we have 3 times cosine 3x plus e raised to 2x sine 3x. The derivative of x squared is simply 2x, and then x squared sine 3x. The derivative of e raised to 2x is e raised to 2x, and then derivative of 2x, which is 2. Okay, so this is just a matter of simplification. So all terms contain e raised to 2x. We could factor that out. And then, so the first term here will simply become 3x squared e raised to 2x. Oh, no more e raised to 2x, sorry. 3x squared, and then simply cosine 3x plus, we have here 2x times sine 3x, and then plus, we have x squared 2x squared sine 3x. Okay, so common din pala yung x. So let's go ahead and factor that out. So x e raised to 2x. So this will become 3x cosine 3x plus 2 sine 3x, and then plus 2x sine 3x. Okay, so we can no longer simplify, and therefore we have arrived at our final answer. Okay, let's go to our problem number 5. So we have problem number 5. Last problem. Y is equal to ln of e raised to x all over 1 plus e raised to x. So find y prime. So what we can do here again is simply simplify this to ln of e raised to x, then minus ln of 1 plus e raised to x. And as we can see here, this one, ln of e raised to x is x ln of e. So minus ln of 1 plus e raised to x. Now the good thing about this is ln of e is already equal to 1. So we are simply deriving y is equal to x minus ln of 1 plus e raised to x. So let's go ahead and get the derivative. On the next step, we have the derivative of x is simply 1. So minus derivative of 1 plus e raised to x, then that is equal to e raised to x only, diba? Derivative of 1 is 0, derivative of e raised to x is also e raised to x. So all over 1 plus e raised to x. So this is just a matter of combining and simplifying. So we have 1 plus e raised to x as our LCD. So 1 plus e raised to x here because this is 1. And then minus e raised to x. So as you can see here, we are already arriving at our final answer. E raised to x minus e raised to x is 0. So we simply have 1 over 1 plus e raised to x. That would be our final answer. That's it for this lecture video. Thank you for watching.